Day 100, honors physics, waves, refraction, speed of light, problem number 56. Essentially what this is the reverse version of the Michelson mirror experiment. Basically, he knew the rotating rate of his mirror. He used that to determine the speed of light, of which he got very accurate results, I think within 1% of today's accepted value for the speed of light, which I have right here, 3 times 10 to the 8th meters per second. So we're going to do this backwards. We're going to assume we know the speed of light, which we do. At what speed, what was the rotational speed of his mirror? Now, I've summarized this in previous days' notes, and I will have, or will show you, the experimental setup in class, hopefully. The idea, once again, is that the light from a source is shining on one of the 8 sides of the mirror, reflecting down to a distant mirror 35 kilometers away, reflecting back to a mirror on the opposite side of the initial one, and reflecting into a viewscope that he sees on the other side. But the bottom line is, we're using this equation, v equals d over t. The velocity is known in this case, 3 times 10 to the 8th. The distance is known, 70 kilometers. So this is the time it takes for the light to travel that distance, all the way down there and all the way back. Well, in the same time, the mirror is rotating quickly 1/8 of a turn to line up with its original alignment so that he can view the light coming back. If the mirror is spinning too fast or too slow, the return beam will not shine into his viewer. So if you take the time for 1/8 of a revolution up here, multiply by 8, you get this. That's the time it takes for 1 revolution. 1.87 times 10 to the negative third seconds per revolution. Now, if you take that and take the reciprocal, the units come out, instead of seconds per revolution, revolutions per second, which I've done, 536 revolutions per second. Now you multiply by 60 to get your RPMs, revolutions per minute. It comes out to be 32,100, but I've rounded off to 32,000 RPMs. We'll talk a little bit more about this in class, but that's a pretty simple, straightforward equation or experiment to figure out, well, for him, if he did this on reverse, if he knows the 32,000 RPMs, he works this all backwards to come up with the 3.0 times 10 to the 8th meters per second for the speed of light. Very ingenious.